Okay, so I think it's time to start. Yeah, thanks for attending this webinar that I will host with my colleagues Will and Paul from Sonidus. It will be about environmental monitoring for urban construction and infrastructure and how to mitigate risks to human comfort and comply with regulatory standards. This is a webinar hosted by Orica Digital Solution, where Syscom Instruments belong to, with Sonidus systems. Don't worry, this webinar will be recorded, and at the end you will get a link that you can share with your colleagues if you're willing to do so. And don't hesitate also to write any questions. There should be a chat box where you can type some questions that we'll have time to answer to at the end of the webinar. So I'm Bart Jacot. I'm the sales director at Syscom Instruments, and Syscom is a Swiss manufacturer of vibration monitoring devices since 50 years now. And we provide vibration equipment for civil engineering applications, strong motion, earthquake applications, safety applications like nuclear power plants, and SHM, structural health monitoring, vibration for modal analysis of structures. And I have the pleasure to host this with Paul MacDonald, who is the managing director. Paul, maybe you can introduce Sonidus and yourself.
Yeah, thank you, Bart. I'm Paul MacDonald, one of the founders and managing director of Sonidus Systems. My own background is in environmental noise and acoustics, so this is obviously a subject that's very close to my heart. And Sonidus Systems is a manufacturer of noise monitoring and dust monitoring instrumentation based in Dublin, Ireland. We work primarily across the construction and infrastructure industries, where there's obviously a high demand for our type of products, but we also do a lot of work with regulatory bodies, cities, country level authorities like the EPA, where we help to take environmental measurements and translate them into easy to understand metrics or easy to access data platforms for citizens. So we take everything right from the compliance regulation at the construction site up to the country level, where we engage on a national platform. And I'm joined by my colleague Will Averdyk today, who's an expert in air quality and can tell you a little bit more about himself.
Good afternoon, everyone. Will Averdyk. I'm the business development manager at Sonidus and look after the European and African markets. I'm delighted today to share with you our systems and solutions for dust monitoring. That's an area where I've been active for about 30 years in developing instruments and supporting them. So look forward to contributing in that part of the webinar. Thank you.
Thank you. Well, thank you, Paul. And this webinar is available because we signed, in fact, between Syscom Instrument and Sonidus System, a technical partnership beginning of this year that would relate to the current webinar related to NVD concept, noise, vibration, and dust, that would be highlighted in the next slide. When we continue here, we'll have a short introduction. Then, like I mentioned, the NVD concept and how this can be used for NVD compliance, regulatory compliance, and how this works with the equipment, the instrumentation, also with the software and the data workflow to provide relevant, let's say, information to the customers. We have two application cases that will present, and after that, at the end, we have a conclusion and some Q&A session. All right, so let's start with the introduction and the NVD. So again, noise, vibration, and dust sources in relation to health, safety, and environment. And it would be mostly based on an urban construction site. And when you look at the picture, obviously, it's not great. When you look at the dust, and you can imagine the level of vibration and noise related to this kind of demolition and so on. And when you have this kind of sites, and it can be, of course, different applications, but when you have these sites, you may have monitoring need before, during demolition, during soil and site improvement, compaction, excavation, etc., to really measure this noise, dust, and vibration. And during the construction, of course, you will have truck movements, machineries, building activities, among others, that would generate I say that high noise, maybe your construction and your structure that would vibrate, move, which is really a problem for human comfort activities and so on. And at the end of the construction and the urban sites that are being reworked, maybe waste management problematics, site cleaning, and so on, that would again relate to noise, vibration, and dust in relation to health, safety, and environment. So the idea is to do something with this noise, vibration, and dust, and understand what's happening again before, during, and after this kind of work. And we've seen the sources, but it's also in relation to the impact behind to health and safety concerns. So especially workers in communities beside these sites. If you have a school, for example, for the kids with the dust and maybe noise, if you have a hospital and things like that, that could be very problematic. Of course, in most of the countries, most of the regions where we are selling and operating these monitoring devices, there would be compliance code of best practices that needs to be referred to make sure that it would lead to government's concern, mitigate project risks, also increase the project acceptance. Imagine, for example, that they will build a new quarry close to your neighborhood. That's going to raise a lot of questions, right? And having levels that were negotiated in terms of vibration, in terms of acceptable noise level, in terms of particulate matter, that would support the health and safety of the communities would be key to accept and increase the acceptance of the typical quarry in this example, but among other things. And in the end, having the public acceptance would probably minimize the financial risks, among others. So basically, with this noise, vibration, and dust, you would like to manage proactively your projects, manage proactively maybe the concerns, and be compliant with the regulation in place. That would lead to hopefully avoiding delays in your project, right? Claims and legal actions that could really jeopardize the projects and even stop maybe the projects, right? Without getting any permits to do the work and things like that. And often when you do some monitoring, you would like to take decisions based on data, based on real information. And for that's typical. You use monitoring devices, equipment that would provide this data to take fact-based decisions. Of course, the goal is to reduce health, safety, and concerns. That would be for the workers, for the population, but also for the maybe structural applications, environmental practices, and so on. So for that, in this NVD concept, noise, vibration, dust, again, Syscom would be the manufacturer of vibration equipment, and we have two products here, MR3003 on the left, and the ROC, which is an autonomous vibration device. And it will be supported with the noise by the Sonitus system. In this picture, it's the EM2030 device, and the dust also from Sonitus with a product that could be a SiteSense, for example. And the question here is, how do you make it easy to use, right? How do you correlate the data together? How do you bring them into one single platform? And for that, Syscom is already using, and you may be aware of that also for the Sonitus Cloud, but the SCS is the Syscom Cloud software. And from Sonitus side, it's the Sonitus Cloud, and we have some gateways between both platforms using APIs, so application programming interface, to communicate between each of the two platforms and provide unique access to the data and information that is per project site. So here, the general idea is to have in the end a trustworthy solution and affordable solution. The positioning of this solution is to provide in 80–90% of the tenders of the problems that you may be facing on the construction site, urban environment, noise, vibration, dust, regulations that would be covered by this solution and give you really the right data set to analyze easily basically what's happening. You don't want to be expert to be able to use this kind of SCS and Sonitus Cloud together. It's still very important to have an easy to install and easy data processing without too many expertise required behind. In fact, the software should provide an easy to interpret, easy to read, maybe report at the end that everybody can understand. And I have to say that both platforms would really fulfill this very clearly, and we'll see that afterwards. And this partnership that I was mentioning at the beginning is very good because Syscom is using expert partners worldwide, and it's very similar for Sonitus, who has also several partners that would be expert in noise and dust, and having this local expertise, local support for, in fact, the local regulations, because it may change by country, would really enhance the solution that we are providing. And having this link that is already pre-programmed would provide a seamless efficiency to the customer and to the user, sorry. And in the end, this is the solution we are putting forward, but all these platforms, in fact, can also, and these products can push data to third parties when it's required. But here, what we're going to highlight is the SCS and the Sonitus Cloud being a unique NVD concept brought to you. And I think Paul will explain that further in the next slides.
Yeah, thank you, Bart. And as you mentioned, making it easy to collect that information, making it easy to run instrumentation on a project is at the core of what we're trying to achieve here. Our experience and what we hear back from our customers is that if managing instrumentation on site and collecting the data is taking up too much time, it means you as a user are not spending your expertise where it's valuable. So the goal here is to highlight the simplicity and focus on the simplicity, that you have a single platform, a single place to take measurements, and simple instrumentation that will allow you to collect that data in an automated way, which means you're then spending your time where it's most efficient and where it's most effective. You're managing instrumentation through the cloud, managing your stakeholders through the cloud, and managing a project or multiple projects in a way that lets you oversee what's happening without minding instrumentation out in the field all the time. So all of a sudden you're spending your time overseeing the projects and bringing the client through to the next phase of their project without spending hours and hours on that instrumentation piece and on that data collection. And at the core of it needs trustworthy systems. So we focus on this a lot in our team, that when a client is delivering data or delivering a decision based on that data, there has to be absolute trust all the way through that measurement chain. And that's both on the cloud-based system, allows you to do that because there's no manual part in that upload. You have a fully automated system that is sending out those notifications and those alerts 24 hours a day, no matter what time zone you're in. And you have a permanent data feed there that's collecting that information. That goes all the way back to the factory. And I know Syscom are the same as us, that they'd spend an awful lot of time on quality control, calibration of the instrumentation, sharing that calibration documentation with all parties so that there is trust in the data integrity all the way through that measurement project, right the way from before, during, and after the project. And obviously, our area is noise and acoustics. This is from a slide we do with training. And what I would say when it comes to noise, there is a huge amount of acoustics and noise measurement application that we could explore. We ran an internal training session for our team yesterday. We had a professor from the local university come in and explain an awful lot of this to some of the newer team members. And the big takeaway was that even on a simple short-term project, you can have an enormous amount of data coming from a monitoring station. And the ability to prioritize what data is important and to analyze that in a way that allows you to make a decision on the project, a decision around compliance or a decision around noise control, is really important. So when we measure noise from our instrumentation, we measure a number of the key parameters that are most relevant for construction projects, focusing on the A-weighted equivalent level. So that LEQA, that's a metric of the average sound energy during a certain time period. It's A-weighted, which means we treat it to account for how the human ear actually picks up sound. The human ear is not quite as good at picking up sound as a microphone would be. So you have to do some digital filtering to account for the fact that we hear certain sounds better than others. And what that means is we're actually measuring a representation of how annoying a certain sound might be in a scenario, and trying to wrap a little bit of context around that mountain of data that we get from a permanent monitoring system. So we measure that. We measure at 1 minute intervals, 5 minute intervals, whatever the local regulations might need. We measure all the statistical levels. The L10 is the level that's exceeded 10% of the time. We measure the L90, the background level at a site. And by collecting all those metrics on a continuous basis, you can build up an understanding of the noise context, both when the construction activity is happening and when it's not happening. And you start to develop a view into the impact or the potential impact of noisy activities. And what we see with noise in particular is that the noise limits can vary by time of the day, time of the night. They can vary, the regulations can change from city to city. And we try to build all that intelligence into the cloud software so that once the data is collected, we can analyze it in a way that makes it easy for the user to present that and then to their stakeholders, and also make a decision on how to manage that noise. So we do that with a couple of products, and what we manufacture tend to be long-term automated monitoring stations. Again, simple systems that are easy to install in the field, easy to set up. You don't need to be an acoustics expert to take a good measurement. And a lot of that expertise and knowledge is then programmed into the cloud platform to allow us to automate that data capture as well. So we have our core products, the EM2030, and that is designed for long-term unattended measurement, captures all the relevant sound metrics that are needed, LEQ, L5, L10. Those are, and the usage of those varies in different regulations throughout different regions of the world, and different local rules. So where we'd see the IEC 61672 as a sound level meter standard, it's mirrored in the US by ANSI S 1.4. And I suppose we're lucky in a sense that that standard is almost universally accepted worldwide. It's a very, very technical standard, very, very well defined, and tends to be used in every country in exactly the same way. And then it's the interpretation of that measurement data that varies from region to region. And next year, we'll be adding to that measurement range with a high-end product called the SoniSense Pro 616, a type-approved system designed for the European market to tackle additional applications like industrial sites and so on. And you can see an example of one installed there. So again, automated measurement designed for regulatory compliance, making it easy to collect the data on a 24/7 basis. Data has traceability for legal proceedings. Everything comes with a calibration certificate delivered through the cloud. And the cloud then is how we interact with that measurement data, sending alerts when a condition is hit that is non-ideal, performing the data analysis and automated reporting arriving into the user's inbox. Again, taking the manpower out of that data analysis, making sure that experts are spending their time giving an expert opinion on how to manage the project. And set up in such a way that these stations can be deployed unattended for years at a time, measuring whatever value is needed, either on solar power, on battery power, or mains power, to give the maximum flexibility for data collection in the field. And I know the Syscom system adopts a very similar philosophy, and Barth can tell you a little bit more about that.
Thank you, Paul. Now back to vibration for the second measurement we're doing here. And in fact, when you're discussing about vibration and vibration, let's say, problematic, you have the structural damage that is the table and the standard that you see on the left, really related to buildings, building monitoring, or like sensitive equipment sometimes. But you need to be careful and follow these norms that are very, I would say, specific by country. So Germany, British standard. In France, you have Circulaire de 86 and so on, the Swiss, Portuguese, and so on. So you have a lot of standards. There may be a little bit of discrepancies behind that. So please refer to your standards in your country. Same for human comfort, which is in a way related to maybe acoustics, because you have also some RMS values, some third octave values, and things like that. Not going too much into details here, but both standards are used. And when you look at the right, this is typically what you get for the DIN 4150-3, a very widely used standard worldwide, with depending on the type of building that you are monitoring in terms of vibration, if it's historical, residential, industrial building, you will have different curve levels that are based on velocities, millimeters per second, inch per second, doesn't matter much, and frequencies. So you compare the frequency content with the peak particle velocities, and basically the system, the STS or the Sonitus cloud, both would report this kind of graphs automatically and raise notifications when you exceed a level that is probably or too high for the point of interest that is being monitored. Next would be related to the dust with Will, please.
So with dust, just to define what we're talking about, we use the term PM2.5 and PM10. This is the size of the particulate or dust. This is related to the smaller particles get deeper into the lung and cause health and dust. Environmental and health and safety issues are driven by health concerns. To put that in perspective, I think it's just over 4 million early deaths worldwide are caused by particulates. Even in Europe, where we have better air quality, it's over 250,000 deaths. And in the UK, now for childhood morbidity, particulate is known to be the second largest cause. So it's a health issue, and that is why we're seeing lowering of limits of PM2, 2.5 and PM10 levels across the EU, and in the UK we use the same limits as well. So there is a change going on at the moment as a result of a recast air quality directive at the end of last year, where basically limits for PM2.5 are coming down from 20 to 10 micrograms, and also equivalent for PM10. But it's interesting that those limits are still above the WHO guidelines of safe levels. So even at these levels, there is still concern from health, and there are pressures to generally reduce particulate. Now, PM2.5, which was this very small particle, less than 2.5 micron, is not visible. You don't see it, but it causes these health problems. And it's interesting to, for example, we take London. Construction in London contributes to of PM2.5. 7% of the PM2.5 is coming from construction, and PM10, it's actually 32%, and that's before you consider re-entrainment. So this is why particulate monitoring, or PM2.5 and PM10 monitoring, is becoming more common around construction sites, because when permits are given, it's important to control the contribution to generally the levels where there are concern about reducing those levels overall, especially in urban areas. Next. So how do we measure particulate PM2.5 or PM10? Well, historically, it was done by collecting on a filter paper. That's not particularly practical for continuous monitoring because of the manpower, very manpower intensive. So commonly we use optical particle counters. We arrange that the particles flow past or through a laser, so that there's a single particle in that laser at a time, and light is scattered by those particles, and the pulse heights, or the magnitude of the light scattered from a single particle creates a pulse, and the magnitude of that pulse is linked to the size of the particles. So therefore we can actually categorize particles in different size bins, and then with assumptions of particle density and shape, we can actually, for different size groups, can actually infer what the concentration of the particulate is. So this technique has the great advantage that it can be simultaneously measuring PM2.5, the particles less than 2.5 micron, and also the PM10. We can also look at respirable dust and total suspended particulate as well. The middle is showing an implementation of such an optical particle counter in our dust sense. There's an inlet where it's taking air from all directions. Flow is from the top going down, pulled by a fan through the optical particle counter. Now, that section above the enclosure plays a very important part because it's a heated inlet. With optical particle measurements, as we know, the reason we see clouds in the sky is that clouds or water vapor or clouds will scatter light. So we don't want to have an interference from mist or fog. And actually, when relative humidity is greater than 60%, particles actually grow. So it's very important to control RH and actually make sure there is no interference from these water vapor issues. So we have a heated inlet. That's very important in any external use of particulate monitors. So air is taken in, is heated, and then it moves through the optical particle counting where it is sized and dust concentration is assessed, and then it communicates via 4G, 5G into the cloud. This particular instrument is the dust sense. As Bart referred to earlier, we have a version where there's a noise monitor integrated with that, which is our sight sense, and both these systems have an MCERTS approval for indicative monitoring of PM2.5 and PM10, which is the appropriate standard for industrial and construction site monitoring. But resilience and robustness is really important with particulate monitoring. Particulate contaminates, water vapor is an interferent, and dealing with this in a robust way is very important. This is what we do with these instruments as well. So how do we, where are these requirements for NVD, noise, vibration, dust? Well, if we look at a sort of, I guess there are sort of four areas. Construction, very important from regulations now and permits. You will see noise limits on construction sites, especially when they're in urban areas. Vibration, it's in terms of actually the structural impact on nearby buildings, the impact on sensitive equipment in nearby hospitals, research labs, and also on human comfort. And particulate, especially in low emission zones, which we're seeing more and more in the EU and the UK, driven by the Air Quality Directive. There are constraints on making sure that we're not contributing significantly to additional levels of PM2.5 and PM10. So these are permit conditions around monitoring particulate. Mining minerals and quarries, again, these are processes which are very dusty, creating high levels of particulate. Particulate has a different, there's an additional concern here because of the, it is also relevant in construction, but there is a concern with particulate containing crystalline silica, respirable crystalline silica is particles defined less than 4 micron, and there are concerns about exposure limits to crystalline silica. But we have the vibration concerns in terms of worker safety and damage, and also noise in terms of the impacts on local facilities. Quarries can be quite close to areas of habitation. Probably they weren't built there initially, but actually people have constructed near the quarry. So there are noise limits as well as vibration concerns and particulate. You see the same in ports, and I would also just wanted to amplify this fourth area, which is tunneling and underground work, especially in areas where there is high silica content or quartz in the rock. There are concerns of respirable crystalline silica. Vibration is obviously a concern in terms of actually what impact is having on nearby facilities, or and again noise as well is a constraint. So you can see there is this commonality of an environmental monitoring of noise, vibration and dust in these 4 sectors. Not always will they all be done, but actually we're seeing more and more where the 3 are required as a common interest. Thank you.
Thanks, Will, for the comprehensive explanations, and that leads to and we've seen either for noise, vibration, does that there are a lot of regulations, right? A lot of requirements behind, and the good thing is that really the concept that Paul presented on the NVD is really to facilitate these evaluations on sites. And now what we're going to see is the software that is holding everything together with, in this case, ROC devices for vibration that are not necessarily located at the same location on the construction site compared to the SiteSense, in this case, for noise and dust that are embedded in a single device from Sonidus. So the data workflow works as following. So you have the equipments, instrumentation, ROC, and SiteSense, in this case, that would push data for the ROC to the SCS, the Syscom Cloud software, and for the SiteSense to the Sonidus Cloud. And we try to correlate these devices, centralize these these measurements, these data into a single platform. And in the end, both platform works, but how do you choose the SCS or the Sonidus Cloud? And that's pretty simple. In fact, it's if the vibration or when the vibration is the main concern, you'd prefer the SCS. If you're already an SCS user, you will keep the SCS. If you're already a Sonidus Cloud user, you will keep the Sonidus Cloud. And when you have noise and dust main concern, then Sonidus Cloud should be preferred. So that's really, I would say, straightforward. SCS when the vibration is the main concern, Sonidus Cloud when the noise and dust is the main concern, but both platforms would display and process the 3 types of data. So specifically now for the SCS, the Syscom Cloud software, Syscom is displaying the noise in decibels, the vibration in velocities, and acceleration in millig's, and the dust would be the particulate matters, micro-G per square cubic meter. And we have 2 types of plot in the SCS, either the continuous background plot or the triggered event plot. And that's how it's processed. So once you're in the SCS, and maybe some people listening to this call already have some ideas how this works, but basically you add a device to the SCS for managing the devices and then managing the project. So you add a device here, and in this case, the Sonidus Sound device, that would be listed in a project and an idle pool of devices that you can assign to a specific project. So it's, again, with the APIs implementation and so on, it's pretty straightforward. You just have to create an account on the Sonidus Cloud, put your credential on the add device Sonidus Cloud, and you will have a list that is automatically populated because of the APIs that are working and are programmed behind. And once it's done, you can assign devices to a project, and that would look similar to that. This is a test project for Sonidius on the SCS. And you see here the project settings with notification that you can configure and reporting capabilities that you can also configure, either with PDF reports and depending of the different plots you would like to get, and also notification, either SMS or per email notifications. Then you can configure also remotely the two devices. Here you see the 8883, which is the Sonidius device, and the ROC vibration device in a single project. You can easily share data with your end customers, with the different stakeholders that would be interested in this specific project. You have a few KPIs for logging modifications, alarming, state of health, and reporting related to this project. And in the end, on the left, what you see is different tabs. So you have the map, where you can visualize your data on a map, an event table for the vibration recording, and a background plot where you can see the noise and vibration data. So it looks like that when you look at the map on the SCS. You see two devices in this case with noise and vibration, ROC and the Sonidius EM2030. And when you look at the background, you see the sound and peak, which would be vibration. But here you see the four curves, like Paul mentioned previously, on the LAF, max LAQ, LA10 and LA90 curves. That would be interesting to get and correlate then with the noise and vibration notifications and automated reporting. So that's quickly done, and I think will have the final words afterwards. But if you would like a live demo, again, don't hesitate to contact either Will or myself, and we'll show you a live demo one-to-one. I think, Paul, it's now back to you to present a little bit more in details the Sonidius Cloud.
Yeah, so thank you, Bart. Very much along the same lines as the SCS, the Sonidius Cloud is designed to make it easier to get the information you need and run your project day to day. So the philosophy we try to take is you do all the setup at the beginning of the project, assign your monitors, add your stakeholders, and then set up your analysis so that as much as possible can be automated from that point on. And then once you get into that stage, you're just looking through layers of data. There are layers of interaction that you need to do either on a daily or a weekly basis. So what we're looking at here is the very first layer. That's at the project level. Checking is everything on, little green dots, everybody's happy, means all the monitors are in good condition and you can oversee it. The next layer is down into the data. So looking at the measurements, that's actually something that's calculated by the web platform. So we take the raw measurements and we look at the hourly values to try and give some context and insight into what's happening. So a simplified layer of data to just understand an oversight on the project and allowing a user to quickly assess, is there a problem? Are we compliant with limits or are we not? Do we have somewhere where we need to drill in a little bit more and drill down into those measurements to understand what was happening? And then a very high level layer is our compliance calendar view. And this is one that's very popular for stakeholder management. So a user of the system can just share this compliance view with their stakeholders in the project, allowing them to see, are we compliant every day? If any of those values is above a limit level, then there'll be a little red box there showing that there was a problem on that particular day. And it shows where to focus the energy and focus the time to try and manage compliance. That particular image we're seeing there is actually from a port in the west coast of the US, and they decided to share that data publicly. So that's a publicly available page embedded into their own company page, so they can share that with the local community to manage their noise emissions and manage that relationship. So a suite of tools there available to manage a project, manage a local community, or manage your data depending on your role in the project and how detailed you need to go for the job you're doing today. And in addition then to the data, we have that same idea as the SCS, the management of a fleet of devices. So a large user with a large fleet will also have that asset management oversight piece where they need to understand, is everything working as it should be? Is everything powered up? Have we got any challenges? Do we need to oversee the data at all, the devices at all, to make sure we have that data integrity we talked about earlier? And this is a very simple overview of managing that fleet of devices, assigning them to different projects, making sure everything's online, and that the data coming in is good. So we have a really nice suite of tools to allow users to assign those devices where they need to be, and get a very quick overview at the beginning of the day to make sure everything is working properly. Now, one of the additional tools that we'll see here when it comes to noise in particular is giving context to some of the data that we take. So we launched this feature a couple of years back, and it's been really, really popular. And it's an automated noise identification tool, or ANI that we call it, built on AI tools to allow users to try to assess some of the context at their site. So if the noise goes above a particular limit, we'll take an audio recording, and then the web platform will try to assess what that audio recording contains. And again, it's a time-saving effort, making sure that users are only spending their time assessing and listening to audio recordings that are relevant sounds for their site. So they can filter through these, just look at the ones that are construction noise, and listen to those to understand what activities are causing you to be non-compliant, or what activities are most likely to cause an issue with local neighbors and local complaints. And again, it's all around that management of a data set, management of the context, and getting to a decision as quickly as possible with the minimum amount of manpower needed. And the instrumentation and both cloud platforms are built around that to allow you to manage that continuously without always having to put in your time and effort to do that. And we have a couple of nice examples that Will is going to talk us through of where these products all come together, and some real world use cases. You get a better feel for it.
Barth, thank you, Paul. Barth, you mentioned the importance of local experts, and this absolutely reflects that. This is in the UK. Our local expert is Campbell Associates that Sonnet has been working as we have a long-term distribution and service support agreement where they are our partner for the UK, and this is a couple of projects where they have been involved, and we're delighted they are also the Syscom local partner as well. So they're pulling these systems together. This is a refurbishment project in near Greenwich Park in London. Again, it's a highly developed part, a lot of residents around, and also quite close to a railway station. And here there was a need for monitoring dust, noise, and vibration. So it's a common thing. What's very interesting is look at that context piece that Paul referred to. Here you can see that actually 75% is that purple segment, which is actually coming from construction. Just under 25% is coming from sort of impact sounds, and a much smaller percentage from vehicles, and a bit also from human voices. So it's really interesting, and this is very typical of a project where we'd have noise, vibration, and dust all being monitored together and pulling all the information together. The second project, if I move on to the next slide, is again another construction project in the UK, supported and provided through Campbell Associates. And this is, it's interesting, this is a very large new construction of a large new distribution centre in the East Midlands. A few years ago, a rail service point was installed here, and in fact there is now new distribution centres going in. This particular project is managed through a large construction company, Winvic, and it's really interesting to see. They've got noise, dust, and vibration on this site. Vibration because of proximity to the rail network, the noise and dust because it's actually very close to a village as well. even though it looks quite a green site here. But it's really interesting to see the context here. You can see the dominant noise source is, in this case, is traffic, which would make absolutely sense because it is a distribution center. There is also some construction and some impact sounds as well. So this context of noise is really helpful when trying to manage noise. But I hope that gives you a sort of sense of sort of projects within sort of quite close proximity to other buildings, these new greenfield sites, but it can also be very similar in tunneling applications, which can be very remote as well, where you'll see these commonalities between noise, vibration, and dust. Good. So today we've covered some really interesting elements of actually first of all this partnership between Syscom and Sonitus in terms of being able to pull together some very best-in-class instruments around noise, vibration, and dust. But it is part of an alliance so that we're actually making our platforms very easy to integrate each other's systems. And that then for our customers makes it very, very easy to analyze the data, but also to use the data to manage the risks around noise, vibration, and dust, and take actions. As Bart mentioned, we can do demonstrations, and we'd be delighted to do separate demonstrations outside this around the Sonitus cloud and also the Syscom cloud. You could they are subtly different. If vibration is probably the dominant part of the requirement, then the Syscom cloud would lead. Whereas if noise and dust is the sort of dominant part, then the Sonitus cloud can be. But in many ways, both systems can be used. But I wanted to thank everyone for their time, and I'm delighted now to open it up to questions. We've got I think we're scheduled for another 10 minutes and would be delighted to have questions from the participants. Thank you.
Thank you, Will. Thank you, Paul. You're right. Now is the time for the Q&A. And maybe, Paul or Will, could you read a few questions? Because I won't leave this screen. Then you have the email addresses from myself, bat.jaco@orica.com or will.averdig@sonitussystem.com for the live demo requests. Maybe, Paul, if you would like to start with one question.
Yeah, the question just, I suppose, you didn't go into too much detail on the instrumentation, Bart, for the vibration. Can you give an example of where the Syscom ROC suits and how someone might decide where they might transition from the Syscom ROC or the MR3000? What type of projects where does the instrumentation?
Yeah, thanks, Paul. Yes, the ROC is an autonomous device with an internal battery that would last for between 6 to 9 months autonomy in a cable-free manner. So it's very easy to use this ROC device when you are on a construction site where you don't need to lay down cables all around the place. So that would be the preferred solution when you have limited power access. And the ROC is also embedded with a small solar panel. So when you are outdoor, you will have more or less unlimited autonomy, which is really easy then to use and transmit data to one of the two platforms here. MR3000 would be more for underground applications where you have maybe no 4G or maybe where you need top accuracy for, maybe some of you know the vibration compliance curves with very, very low sensor self noise when you need to measure VC, E, F, and so on curves.
Yeah, I understand. And we get very similar applications, I suppose, on the noise side. We have 95% of what we do is quite straightforward, and our EM2030 is an ideal fit for that. And then occasionally we would get much more involved noise applications like wind farms or very detailed acoustic assessment where we need to switch on some extra features, or that's where our SoniSense Pro will come in next year.
Yeah, perfect.
I have a question from about can your instruments monitor respirable dust? Yes, respirable dust is becoming more important because of this crystalline silica issue. And just to clarify, respirable dust is PM4. It's the particles less than 4 micron in size. So the dust sense and the site sense can measure PM2.5, PM4, which is respirable dust, and PM10, and also total suspended particulate, where it's actually larger particles than 10 micron as well.
Perfect. And thank you, Will. There's one in from the audience. Maybe Bart, you can start us off. How often do the devices for NVD need to be calibrated? So maybe you can answer for vibration.
Yes, so you're right. It depends on the sensor type. So for vibration, it would be related to velocity geophone sensors. And for Syscom, the geophones would be, it is recommended to calibrate these geophones every 2 years. Some of our customers are doing that every year, but from factory, we would recommend every 2 years. And when you are using, I mentioned also in one slide, acceleration sensors, and some standards are referring to acceleration, and in this case, Syscom is using MEMS-based, so very small micro electromechanical system embedded on a chip that would be very stable over time and do not require any recalibration. I guess for noise.
Yeah, I can answer on the noise side. So exactly the same. We aim for every 2 years. We recommend calibration in the laboratory, and that's a laboratory calibration where the microphone and the data logger are calibrated together as a single measurement chain. There's a very well-defined piece of that standard that defines what the calibration test is. There is a field calibration that can be done with an acoustic calibrator in the field. You pop it over the top of the microphone, acts like a sanity check. The need for that is really dependent on how formalized your measurement scenario is, and whether you're going to be presenting the data in a legal scenario and so on. But we recommend every 2 years to stay compliant with international standards for noise. And then on the air quality for the dust monitor, we recommend the same thing, a calibration of the measurement module. So we'll show the screenshot there, the cutaway of the front of the dust sense. We send out a pre-tested, pre-calibrated measurement module every 2 years, and that's a simple swap out in the field. We do have applications where that service interval can be lower. So for example, we have a mining client in Canada where these are installed down in the mine or on the ramp. It's a very, very dusty environment, and because there's optical components in there, over time they can become coated by heavy dust. But that's a really, really heavy use case for a construction site, and ambient monitoring at a busy construction site. 2 years is quite sufficient.
Perfect.
So we have one in there, follow-on question: where could the equipment be calibrated internationally, such as in Canada?
Yep. Again, I think it depends on the instrument type, but for Syscom, we have 7 or 8 calibration test centers that could be found on the website. So there would be in Europe, there would be one site you can have a look at the website, the Syscom website, and the calibration center, and you will have a list of all the calibration centers available. Of course, a headquarter would be also able to do that at Syscom in Switzerland.
And quite similar then for ourselves, we ship out those pre-calibrated modules for the dust sense, calibrate in our laboratory. Customers can work through our international network of distributors there. For noise monitoring, one of the requirements of that technical standard is that a device should be able to go through any third-party laboratory. So we can certainly work with local laboratories, but we also have that network of distribution partners. And Sonida Systems is now part of Cognisense Group since the end of 2024. And into next year, we'll have a service center in North America as well, where all of that instrumentation can be serviced out of that base, just to help with logistics.
Perfect. Maybe one last question, Will, if
Yes,
there's one. Yeah.
The question is, in addition to vibration, noise, and dust in residential areas, can you also, what about broader air quality measurements? Yes, we have experience of integrating NO2, O3, ozone, and SO2 monitors into our systems. We have some good experience about selecting ones which we can depend upon. So we don't actually manufacture those systems, but we can take the view of sort of making sure quality is right there and integrating it, so it's a complete system.
Perfect. So just as a reminder, I think that so the webinar was recorded. You will receive all the link with the live recording. Also, if there were some questions unanswered, I think we have the list, so it will be split between Will and I probably, and then we'll get back to you directly afterwards with a straight answer per email. And I'll reiterate what Will mentioned for the live demo. If you're really interested in getting a Sonitus or a Syscom cloud software demonstration, don't hesitate again to contact us directly, and we'll be very glad to present you more in details and the live access and sharing our screens for that. Thanks again for attending this webinar. It was a pleasure, Will and Paul, presenting with you, and that would be it for the day. Thank you.
Great. Thank you for all the effort, Bart.
You're welcome.
Yeah, likewise. Yeah, thank you.
Thank you. Bye-bye.